Hello everyone, I am Somesh Janapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. In this class, we will discuss difference between bending moment and moment of resistance. So first, let's go to bending moment. What is bending moment? Bending moment is your reaction of structural element to an external force or moment. Like the structural element here, let's take it as your beam. So, when we apply an external force in case of any beam, the reaction occurs in that beam is your bending moment. Okay. So, next, what is moment of resistance? Moment of resistance is what? The internal force within that beam. If here this is your beam, when there is the external force, to resist that external force we have one internal force, and that internal force or resistance force is your moment of resistance. Next, what? Next is the sum of the moment of all external forces acting on one side of a section of a structural element. Yeah, like if we have the beam, that is AB. So here you can see that we have 2-point load and in the middle we have one UDL. So the sum of all the forces acting, we will calculate that along one side of the beam. So that will be termed as your bending moment. Bending moment calculation will be done by this point load into the distance, with this point load into the distance, and UDL with the distance from one side of the beam. Always remember, we will calculate the bending moment at one side of a beam. You can take it as right side or you can take it in left side. Next, what is moment of resistance? That the couple formed by the internal forces in a beam under maximum permissible stress. When there is lots of forces or lots of external forces, so the internal force will form a couple to resist the external force. So those couple under maximum permissible stress is your moment of resistance. Next, the resultant internal couple that causes bending. So when to resist the external force, there will be the formation of internal couple. That internal couple, when applied in case of beam, that will bend the beam. Okay. So that will causes bending of beam, and by that the beam will bend little bit. The next, the movement of the couple formed by the longitudinal internal forces of opposite nature and equal magnitude. So, the couple which was formed will be what? The longitudinal internal force will be opposite nature but equal in magnitude. Like the nature will be opposite, but the amount or the quantity will be equal with the external force. By that, the internal force will resist the external force. Similarly, equal and opposite to the bending moment are the section where the couple acts. Always remember that the internal force will be equal with what? Our external force. Otherwise, if anything little bit ups and down, then there will be problem. So always remember that internal force will be equal with the external force, and the forces act will be opposite nature. Okay. Next is your what? Modulus of section or section modulus. So what is modulus of section? The modulus of section or section modulus is the geometric property that measures cross-section's ability to resist bending. So we have different types of cross-sectional beam. The beam can be square, circular, or rectangle. A beam can be circular, square or rectangle. We can take any kind of beam. So the modulus of section is geometric property that measures cross section ability to resist bending. Okay, it is nothing but your calculation of ability to resist the bending. It used in structural engineering design, beam and other flexural members. We have the equation already that m by I equal to f by y. In our previous class, we have discussed that bending equation. In that equation, we have already proved m by I equals to f by y equals to E by R. So, E is your Young's modulus. These two things will not required here. So we neglected that, but we need m by I equal to f by y equation here. So m is your what? Maximum bending moment occurs in your structural member. Right? Next I. I is your what? Moment of inertia. F, we already know that F is your stress and Y is your distance from neutral axis. Okay, N is your neutral axis. So from this equation m by I equal to f by y, we know that if the distance of neutral axis is larger, then the stress generated will be maximum. The stress generated will be maximum. Okay. So now we will take this equation we have the equation as m by I is equal to f by y. Now, if we have maximum stress, so let's take it as small f because capital F represents your force. F max will be m by I into y max. When this distance is maximum, the stress will be maximum. Now we can write that m will be your f max into I upon y max, right? This I upon y max term will be your z. Z is what? This modulus of section or section modulus. Z is what? Modulus of section or section modulus. So you can say the moment of inertia at neutral axis, distance, maximum distance from neutral axis will be termed as your section modulus or modulus of section. This term will be your Z. We will represent the modulus of section or section modulus in Z. So, in this class we have discussed about difference between bending moment and moment of resistance and also modulus of section. In our next classes we will learn about calculation of this modulus of section for different sections like circular for circular section, rectangular section and square section. We will know in this in next class. Thank you so much.